Chapter 11, Section 2 is going to go over these rational functions that we started to see from Section 1, but more specifically, we're going to talk about what the graphs look like and how to find some of those points that I referenced when I was in Section 1 called asymptotes, and those are some of like our boundary lines that we're going to have on our graph that kind of gives some parameters for where your graph is going to be at. Now this big chart here really goes over a lot of the key things to know about like your parent function if you were to be looking at that. So the parent function is if you had y equals 1 over x, and remember with fractions like this we cannot have x equals 0 because that would cause this to become undefined. So when we graph these types of functions, these rational functions, like we saw in Section 1, they're going to have like those two branches to them because you're going to have kind of this point in the middle of the graph that isn't going to work for them because it would be undefined. So when we're talking about the parent function, if the number on the top starts changing, so if it's not a 1 anymore, it starts changing to a 2 or 3, or it could be a negative number or something like that, depending on what type of number you have is going to change what the graph looks like. So if that number on the top is greater than 1, that's going to stretch your graph, which is going to make it grow a lot faster. If it's between 0 and 1, that's going to compress your graph, so it's going to make it grow a lot slower. And if your a value is less than 0, so if that top number happens to be negative, that's going to reflect across your x-axis. So it'll still look like your other graphs that you've seen, they just may be in a different spot on your graph than you're used to because it'll reflect it over. Then if we start adding or subtracting numbers to either the bottom of the fraction or outside of that fraction, that's going to change where the graph is at. It's going to move it around, so it's going to be shifting it left, right, up, and down. So if you have a number underneath your fraction, that's usually where they put h at, that's going to be shifting it horizontally, so that's going to move it left or right. And if you have a number on the outside, so like where they have this plus k, that's going to move it either up or down. So the parent graph, like I said, this y equals 1 over x tends to look like this, where the really only limits that we have on the graph is that we can't have 0 in the bottom, so you can't have x equals 0. And so this is kind of the general shape that you're going to see in our graphs today. So part of it, one of the branches is up here in quadrant 1, the other branch is in quadrant 3. And as we get into some examples today, you'll see how things can change, like where they're going to be placed at in the quadrants, or if it's going to move the graph left, right, up, down, if it's going to reflect the graph, if the graph is going to shrink or compress, all those things that I just summarized. So for example, if we had something that looked like this form, so this is kind of showing you that general form that I had kind of gone over with what the a, the h, and the k all mean, and they're giving us this example, 1 over x minus 4 plus 6. So that minus 4, that's in that h spot. And so remember, that's going to move it left or right. So that's that vertical asymptote. And so we would take this number here, and you always pull like the opposite sign that you see. When we were graphing a couple chapters ago with quadratics and dealing with those translations, I always said to think about the opposite sign from what you see is what you're going to be graphing. So when you see a minus sign, you think left because it's negative, but really it's going to go to the right. So we're going to pull a positive 4. So that would be your vertical asymptote, which means that we're going to have like this line at x equals 4. So if I come to my graph underneath here, x equals 4 would be this dotted line that they have kind of going up and down. So that's one of our boundary points there. And then the other one is that plus 6 that's at the end of the equation. That's going to be your y equals 6. So that would be for this one a horizontal asymptote. So if you come to this graph, you go across here at 6 on the y-axis. And so those lines, a lot of times you'll see me draw them in red and they'll be dotted lines. Those are going to be your boundary points for your graph. So you'll notice like my branches, they don't ever cross those dotted lines that I have. Those kind of are like those parameters that are going to keep your graph in this very specific area here on the coordinate plane. So in order to help you find your vertical asymptote, you're always going to take the bottom of that fraction and set it equal to 0. So that x minus 4, you're setting that equal to 0, and you add 4 over, and you got that 4. and I had just done that by taking the opposite sign. So you can set it equal to 0, or if you understand the movement there, you can just grab the correct sign. And then the 6 really doesn't change, like it's positive 6, so we just pull positive 6 here. Now, when you go to graph your branches, once you have these asymptotes kind of figured out, you're going to want to plot at least 1 point on each side of the vertical asymptote. So that would be all based off of that x value. So you can see on my table here that I have points 2, 3, and 5. We skip over 4, and that's because if I put a 4 into my denominator, that would cause this to become undefined. So I skip over the 4 and I do some points on either side of that. And I think there's another point here, I just don't have it in my chart, where it's 6 and 6.5. And so if I go to the graph here, 2, so I went over 2 and I went up 5.5, that's right there on the graph. And at 3, I'm up at 5, which is right there. So you just need a couple of points, and then you'll have to just kind of connect them and create that curved branch. So this would be one side of the graph. And then if we go to those other points, like 5, 7 is right there. 6 is at 6.5. Right there, so you can see then that they kind of connected those points. So let's take a look at an example here together, and we're going to do the whole thing from scratch. So I have y equals -3 over x plus 2, and then minus 1. So the first thing that you want to do is find your asymptotes. That way you can graph those lines that are going to be your boundary areas. So remember, for your vertical asymptote, you take the bottom of the fraction, so that x plus 2, and you're going to set that equal to 0. So in order to solve that, you guys would subtract 2 from 0, so you'd have x equals -2. So that's going to be your vertical asymptote that we'll draw in. And then the horizontal comes from the number that's outside of the fraction, so that -1, and that's going to be your y value, so y equals -1. The next thing I would do is see if there's a stretch or a reflection. So that's when you want to look at the top. So that's this a value up there, which is a -3. So that tells me a couple of things. This is going to stretch because it's a 3, so that's greater than 1, so that means that this graph is going to maybe move a little bit faster than the parent graph would. But it also is negative, so that's going to tell us that it's going to reflect the graph. So back here, when I looked at the parent function and this example I went through with you guys, you know, most of this is kind of like on the top right corner and the bottom left corner. What's going to happen for this one is it's going to reflect over the x-axis, so our branches are going to be in the opposite coordinate quadrant. So you're going to see one kind of in the top left, and you're going to see one in the bottom right. Okay, so let me show you, after we've kind of got those things identified, how we're going to graph this. So I'm going to start by drawing in those asymptote lines. So up here, that would be these two, x equals -2, y equals -1. So -2 on your x-axis would be 2 to the left from 0, 0, and you're going to draw your first asymptote going down through that point. And again, I use dotted lines to represent that. Because it's not really a line that would show up if you graph this on a calculator. It's just going to be there. So that's why we do those dotted lines, because it's not really a line that we're graphing. It's just kind of an area that's kind of like a, you know, think of it like as almost like a force field or something around that graph, that everything's going to kind of make it bounce off of it. It's not going to be able to pass that line. And then y equals -1, you're going to go down 1 from the origin and draw this line going through y equals -1. Now, to get some points for us to graph, I'm going to create an XY table. And remember, I said that what you do is you pick a couple points that are on each side of the vertical asymptote, so 1 point on either side there. So that vertical one was your x value. So what I normally do is, we said that x was -2, so I put -2 in my chart here, and I just draw a line because I'm not going to actually be able to evaluate at that point. And then I put some points above and below it. You only need to do at least 1, but I like to do 2 just so I can kind of see where my graph or my points are going to connect. So I'm going to do -4, -3, and then -1 and 0 on the other side. Now, to find the y values here, you have a couple options. You can plug in your x's to your original equation here, or in the past, we've been using like our yellow calculators a lot. So you can type in this function to that yellow calculator, exactly how you see it here, and then evaluate. So if you don't remember how to do that on your calculators, you guys would press your table button, and it would show up y equals, and then you're going to type in the function. So you're going to do negative, like I would hit your fraction button, that n/d button that you guys have used before, put a -3 on top, put your x plus 2 on the bottom, then get out of the fraction and make sure that you have -1 after that. Then you can go to your table and you can find these points right away. Like you won't have to do a whole lot of punching, and that you can just go ahead and look at the table and it'll give you all the points that you need. So at -4, you get 0.5 or a half. At -3, you get 2. -1 is -4. And 0 is -2.5. So now what I'm going to do is come in here to my graph. I'm going to graph these points. So I'm going to go -4, so that's 4 to the left, and I'm only going up a half. So about there. Then I'm going to go over left 3 and up 2. Okay, so I've got these 2 points. So when I go to draw it, I'm going to want to create that branch kind of right there. It's going to be that curved shape, so it's not going to be, I don't want to see stick straight lines here because it can't pass those red dotted lines, so it's going to be this curved shape here. Now let's do the other side. So we're going to go left 1 for that -1 and then down 4. Then we're at 0, we're going to go down 2.5. And then you're going to draw that branch in. And again, it's going to be very similar in shape. It's going to be that curved line. It is not going to go past those red dotted lines. It's going to get as close to those lines as it possibly can, but it's never actually going to cross them. So I want you guys to take a look at this next problem here. This is a practice problem for you guys, and I want you to do the same steps that we just did. I need you to identify your vertical asymptote, your horizontal asymptote. What is your A value? Be able to understand like where your graph is going to maybe be at. And then use your calculator if you want to type in your function to get that table so that you can sketch the graph. So go ahead and take a couple minutes, pause the video and do that, and then keep watching when you're ready to see what the answer should have been. So to find your vertical asymptote, and I'm going to abbreviate that with VA, and feel free to do the same, you would have set the bottom of that fraction equal to 0. So x minus 3 equals 0. You would have added 3 over, so you would have gotten x equals 3. So there's one of your boundaries. Now that horizontal asymptote, that comes from the number outside of the fraction, so at the end here, which says plus 4. So y is going to be at positive 4, so there's another boundary. And your A value is that 2 that sits on the top. All that's going to tell me is that my graph is going to be stretched. This one is not negative, so it is not going to be flipped at all. So I'm going to draw those 2 lines in first. So x equals 3 would be 3 to the right, and it's a vertical line going straight up and down here. Then y equals 4, you're going to go up 4 and draw that line in. Okay, now to create a little xy table here, you want to base all those points off of your vertical asymptote. So that x equals 3. So again, if you put 3 in the middle like I do, just make sure you draw a line because you can't actually evaluate at 3. So 1 and 2, 4 and 5 would be points that I would want to look at. And then again, you can use your calculator to type that in. And I got 3, 2, 6, and 5 for my points. So now I'm going to sketch those. So I'm going to go over 1, up 3, over 2, up 2. So there's one branch. Then I'm going to go over 4, up 6, and over 5 up 5. And draw that branch in. So hopefully you're seeing how, these aren't necessarily the same as that parent graph. I mean, they have the same shape and everything, but they are moving around your coordinate plane. And that's really all based on those numbers that they've been adding into your problem. It's changing where you're going to be at on the graph. Okay. Now let's take a look at another situation that you might run into here. So we're talking about something called standard form. So this looks a little bit different than what we saw before because there's an expression, there's a binomial on the top and on the bottom here. The bottom looks fairly normal because we saw that on those last couple of problems. You had x plus or minus a number. But on the top, we just had a number before. And now it says 2x plus 3. So I want to go over how do you handle a situation like this. You do everything the same for your vertical asymptote. So you just take the bottom of that fraction, you set it equal to 0, and you solve for x. So they took x plus 1, they set that equal to 0 here, they subtracted 1, and that's how they got x equals negative 1. So the vertical asymptote is handled the same way. The difference here is the horizontal asymptote. So the horizontal asymptote is you're going to take the leading values here, so those leading x terms, so the 2x and the x, and you're going to stack those on top of each other. And those are going to change, depending on what type of problem you're looking at. The top could be a 3x and the bottom one could be an x, or it could be 5x over 2x or something like that. So when I see this 2x over x, what I can actually do here is the x on the top and on the bottom are going to cancel each other out. And so my horizontal asymptote is going to just break down to a 2. Which this is the same thing then as y equals 2. So if you see that situation where you have x's on the top and on the bottom, you want to make sure then that you set them up like a fraction, reduce what you can, and just take that number. Okay, so now let's graph this. Again, I'm going to start by drawing in my two lines. So I have one at x equals negative 1, which would be right here. And then the other one is at y equals 2. Now again, you can use your calculator to help you out with the table. I'm going to put negative 1 in the middle. We're not going to evaluate at that point though. And I'm going to put negative 3, negative 2 on top. 0 and positive 1 beneath it. I would type in that equation that I had, that 2x plus 3 over the x plus 1. I would type that into my calculator here, and then I would get my points. So at negative 3, it's 1.5. Negative 2 is 1. 0 is 3. 1 is 2.5. And then I'm going to grab those points and put them over here. So there's my first branch. And here's my second one. Alright, so I want you guys to practice this. So go ahead, pause the video. Try this one, and then keep watching when you're ready to see what it should have looked like. So to find your vertical asymptote, you're going to set that 2x minus 6 equal to 0. I would add 6 over first, so you have 2x equals 6. Then divide by 2, so you're going to get x equals 3. So there's your vertical asymptote. Now the horizontal asymptote, we're going to put that 4x over the 2x. I'm grabbing those leading terms there. My x's are going to cancel. I'm going to have 4 divided by 2, which is just going to be 2. And so that would be your y. So y equals 2. Okay, then you also needed to create an xy table. Put 3 in the middle from your x equals 3. Don't evaluate at that point though. pick some numbers above and below here. I got negative 1.75, negative 5.5, 9.5, and 5.75. So drawing in these dotted lines first, one of them is at positive 3 on the x. And the other one is at positive 2 on your y. And then we're going to graph these points. Come out a little bit more here. So there's the first branch. And there's the other one. So that's what that problem should have looked like at the very end. Alright, I've got one more scenario to show you guys. So this one, again, is a little bit different than what we saw because previously, before we dealt with the situation that we just talked about, you had just like x plus or minus a number in the bottom. And like we saw in that last example and the one before that, it had a number in front of your x term. So like this one, the bottom says 3x plus 12. Now the vertical asymptote, again, is handled the same way. So you're still just going to set that equal to 0 like they're doing here. So they subtracted 12 and then divided by 4. So they got their vertical asymptote to be x equals negative 4. Now the horizontal asymptote, if you were to grab like the leading terms, like the first terms here, you have 2 over 3x. Well, this doesn't reduce the same way that it did on the last problem because there's no x on the top for it to just cancel and be 2/3. So we need to talk about like what is actually happening here so that we can understand where the horizontal asymptote is going to be at. So if I were to look at this fraction, 2 over 3x, if I were to put in 1 for x, I would get 2/3. Which is the same thing as 0.6 repeating. Now if I put in a 10, I would get 2 over 30. If I put in 100, I would get 2 over 300. And the last one would be 2 over 3,000. So if I look at these numbers, if I were to actually start dividing them on my calculator, you're going to notice that they're going to get smaller and smaller and smaller and smaller and smaller. Now they're going to be approaching 0. They're never actually going to equal 0 because I don't want to put a 0 in here for x because that would cause this to become undefined. So it's going to approach 0, which would be your horizontal asymptote. So it's going to be actually on the y-axis. So a lot of times when you see these cases show up, your horizontal asymptote is going to be a number divided by some quantity with that variable in it, and it's going to become smaller and smaller gradually. And like I said, it's going to be approaching 0. It's never going to actually equal 0, but it's going to try to get as close to that point as it physically can. So let's create our XY table here really quick, and then we'll go ahead and graph this one. So remember that vertical asymptote was at x equals negative 4, so I'm going to put negative 4 in the middle and do like negative 6, negative 5, negative 3, negative 2. And again, I would really be utilizing the table function on that yellow calculator. It makes doing these tables so much faster, and you don't have to worry about typing in things over and over again. It also prevents people from making mistakes when they're typing things in if they don't know how to type it in correctly. So I would highly encourage, if you haven't been using your yellow calculators, to try to get used to using the table, because you're going to see us use it here in algebra, but we also are going to use it a lot in algebra 2. You may even use it in geometry next year, so I would just get comfortable with that. At negative 6, I'm at negative 0.3 repeating, and negative 5 is negative 0.6 repeating. Now these are decimals, and we get some of the same numbers on the positive side of things. They just flip signs. So you're going to have to do your best when it comes to graphing. You're going to have to estimate where you think those points are at. So our horizontal asymptote was this y equals 0. So like I said, that's going to be on your y-axis here, or your x-axis. And that other point was x equals -4. So you're going to go over 4 to the left and draw your line going up and down. I maybe should have moved my graph over a little bit, but that's okay. We might just run into my table here. Oops, I got to go -1/3. So there's one side of your branch. Sorry that it's running into my table there. And then there's the other one. Okay, so there is a practice problem for you to try. So go ahead and see what you can do with this one here, and then like before, go ahead and keep watching when you're ready to see what it should have all looked like at the end. So getting started with your vertical asymptote, you should have set your 3x minus 4 equal to 0, and that should simplify to 4/3, or 1 1/3 if that's helpful for you when it comes to graphing. The horizontal asymptote, you have that 5 over 3x, which these are going to gradually get smaller and smaller and smaller as you start putting bigger numbers in for x, so you get 0 for your y. So just like on that example I showed you. For your table, it's all based off of that vertical asymptote, so that 1 1/3. Now, because I have a fraction here, you don't have to keep the fractions for the rest of your points. You can go to those whole numbers that are above and below. That's going to make this a little bit easier on you, mathematically wise. And then let's graph. So I'm going to go over 1 1/3 and just kind of roughly estimate where I think that's at to draw that first boundary. And then the other one is on the x-axis again. And then plot your points. So that is what that one should have looked like.